Hello, and welcome to the second normal form. Okay, now that we got through the first normal form, it's time to move on to the second rule of normalization, which is called the second normal form. We'll talk about what this is, how to recognize that your table is not in second normal form, what second normal form does, what does it accomplish, how to apply the rule, and then we'll go ahead and show you an example of it. I find the second normal form is going to be new to you, but it's also very important to you. This is what's going to basically finish your databases. Everything you've done up to this point got us pretty darn far. This will take us to that next level that will make sure that our databases are completely normalized, completely scalable, completely accurate, and completely efficient. All right, so let's get started. The second normal form states eliminating repeating redundant data from our table. This can be groups of data that are all related to each other or individual pieces. Regardless, we want to eliminate redundant data. The purpose of getting rid of this redundant data is basically that. If it's in our database over and over and over and over again, it's sort of inefficient. We should represent it one time. And now that you guys understand the concepts of primary keys and foreign keys, you can see that we could basically represent a piece of data with a foreign key. That's kind of the goal. So how do you recognize that a table is not in second normal form? You're going to analyze the data within the table. This is the situation you're not really looking at the columns, but you're looking at the data. You recognize the data in the same columns that is redundant. So it could be city, for instance, might be one. State could be one. Gender could be one. Ask the following questions to determine the need for accuracy. Because there is redundant data doesn't mean necessarily that we want to bring it out to its own table. And we'll talk about that a little bit more. But we want to understand this. How often does the redundant data occur? Is it every other record or 1 out of 1,000 records? Based on this, we need to ask the question, is it worth it? Can we maintain it? Is it worth joining back together again? So we'll talk about that a little bit more. Is the data important or critical? Will redundant data likely be to cause a problem? Meaning we have redundant data in our database. If we try to search on it, which is actually where the next one is, or sort on it, can we do it if it's not the same? If somebody spells Nields incorrectly and I want to search on Nields, would that cause a problem? It could. So if that's the part of the redundant data that is it critical and does it involve, columns that we're going to be searching on, we want to make sure we break that out. That's the whole idea of second normal form. Does that make sense? Okay. So what does it accomplish? The whole idea of second normal form accomplishes the following: data integrity and accuracy. I look at these two pretty much the same, but the accuracy comes from the fact that we don't want data in our database that is not accurate, meaning we don't want a bunch of data in our database that might be spelled incorrectly or spelled different ways, especially if we want to search on it. And so if that's the case, it's not accurate. If it's not accurate, it's useless to us in our database. Okay? So with that said, that's what the second normal is accomplishing. We're going to put it in our database and represent it one time, and thus it will always be accurate. Elimination of modification anomalies. So if we need to allow to update something, let's just say, I'm trying to think, if there's an address that, or not so much an address, if there's something that's out there that's redundant and we need to update it. If it's in our database a billion times and it's redundant, but we need to change it, going through and changing a billion records, billion might be high, but you get the idea. It could be an issue. With that said, the best thing to do is just update it one time. And that's what we're trying to accomplish, the second normal form. So how do we apply this rule? Well, we're going to create a new table with a name representing the redundant data, for example, T instructors, T cities, very similar to what we did in first normal form. We're going to create a unique primary key for the new table. Same thing we did. The new table, though, in this case, is going to become the parent table. And therefore, the table that it originated from will be the child table holding the foreign key, representing the primary key of the new parent table. What we're going to find out here is this, is that with second normal form, the relationships are always going to be one to many. where the new table is going to be the parent table and the originating table is going to be the child table. Does that make sense? We're going to move all the attributes representing the redundant data to the new table and delete all moved attributes from the child originating table, replacing it with the foreign key of the parent table. Once again, I'll show you an example, but I want you to understand these steps as we apply this rule. Okay? All right, let's go ahead and do this like we did last time. In doing so, we'll get back into the problem that we were working on. And we kind of look for opportunities in this case. Since we don't really have redundant data, sometimes when we're first doing our databases, like in this case, if we don't have data in them, it's going to be really hard to recognize second normal form. So then we just got to kind of look at things that could potentially be redundant data. Once we start populating it, can we change it? The answer is yes. There's no doubt about it. We can go back and apply the second normal form when we start seeing redundant data. But in this case here, some of the things that we actually would see, we can very easily recognize as potential redundant data. Okay? And so if we go look at, in this case here, our database, our Excel spreadsheet, if you will. What's redundant? Well, if we look at this right here, we have Florence, Florence. We see Ohio, Ohio, Ohio. See how this is redundant? We see instructor. Whoops, where do I go here? There we go. Doug Bowling, Doug Bowling. And if we go over here, we might see more Doug Bowlings and Larry Kings and Lori Rich. This is redundant data. Now that's actually in our database. So if I wanted to search on Doug Bowling and tell me all the courses that he taught, if he's in my database quite a few times, of course, everything is spelled correctly. But if somebody fat-fingered this, okay, and actually spelled his name like this, based upon what you know about SQL select statements, and I said, go get me everybody who's equal to Doug Bowling, you would know that this would not come back because it's not equal to it. That could be an issue. Thus, our database is not accurate. That's why we want to do this. Okay, so let's go in here and apply it. So in this case here, what we would do is we saw that city and state had redundant data in it. What do? Well, we create a new entity. We name the entity based upon what's redundant. So in this case, we'll call it cities, like this. We'll create a city ID, which is the primary key. We'll actually put the word city in here, just like this. I'm going to go ahead and delete this one. And then as we said before, what we're going to do is now replace this data here. Whoops, sorry. Back here. And we're going to replace this data here with city ID, which will now become the foreign key. Whoops. Come on, hit on it. There we go. Got a touchy mouse here, okay, or touchpad. And so we have with the foreign key, and now this is going to be, if we look at our relationship, and we'll make this straight, this is going to be a 1 on this side to many relationship with that particular table. So 1 to many. See the crow's feet? So now what we've done is we put city, what we're going to have is one row with the city in there. And so in this case here, the city could be Florence. And then that Florence, so we could have the primary key 01 with the city of Florence. It would then be represented in this new table as 01. So now instead of Florence being redundant in our database over and over again, it's represented only one time. Does that make sense? Pretty simple, hopefully. But again, now we're basically making sure only things in our database are represented one time. All right, so we got state. I'll go ahead and do this quickly for you. State ID. And then we'll put state right here. I will go ahead and delete this. I'm going to do a quick copy on this and paste it. There you go. And it's going to look very similar to this. Okay, and then I come up here and I'll make this state ID. And once again, do a right click. There you go. Foreign key. So let's make sure you can see this pretty well. So now look how our database is growing, but now it's accurate. So now instead of state, say I had 1,000 students in my database. So instead of the same states showing up over and over and over again, only 50 states will be on our state table, or however, whatever amount of states you want, but a maximum would be 50, obviously, right? So with that said, the maximum amount of states would be in our state table, and each one being represented by a primary key, and that primary key will now be the foreign key in my students table. So if I had 500 students from Ohio, instead of me spelling out Ohio 50 times, or 500 times, I should say, it would just be represented by a key, a foreign key. You get it? So one to many. Our final piece here was the course instructor. We saw that that actually repeated. So we will go ahead and do the exact same thing here. So in this case, we'll say instructor, instructor ID, and maybe, I don't know, first name, last name. Maybe there's a lot of things where, well, probably we might want address and all kinds of things on the instructor in our database. But regardless, it's these all represented by one primary key. So with that said, we would make this the instructor ID. This will become the foreign key. I keep hitting on the wrong area of my trackpad here. There we go. Foreign key. And I'm going to go ahead, and this, once again, is a one-to-many relationship with my course table. Now I can have Doug Bowling in there. I can represent Doug Bowling on any course just by representing the foreign key, but he's only in my database now one time spelled correctly. So thus, if I want to search on Doug Bowling, he's only in there one time. And if I, I hope I don't spell it incorrectly, but at least if he taught 1,000 classes, he's only in my database one time, and I can search on Doug Bowling very easily because he'll be represented in my course table by the foreign key. What do you think? To me, this is the one that you really want to grab, and this is the one you really want to understand. As I stated before, based upon how we did our design up to this point, we kind of took care of first normal form in most cases. However, it's important that you still look at tables and make sure they are in first normal form. So second normal form once again says this, that everything needs to be in first normal form, and then after it's in first normal form, you look at second normal form, and we eliminate any possibilities of redundant data. Once again, should we eliminate everything? That's a big question, because what we need to be able to do is we need to be able to maintain these particular tables, okay? So can we maintain all the instructors within Cincinnati State? Yeah, pretty easily. We know it's a finite set. Can we maintain the states? Yes, it's a finite steps also, or finite set also, I should say, meaning there's 50 states. There's no more. All right, if they add a 51st, wouldn't be that big a deal to go add one. Cities, that gets a little tougher. There's a lot of cities in the country, and there's new cities popping up all the time. Can we maintain that table with every possible city in there? That's something we need to consider. Based upon that, are we going to search on it? If the answer is no, maybe we don't break out cities. You can sit back and start looking at all these things, right? Let's look at a couple other ones real fast before we end here. Name. There's quite a few people with the last name of Smith, right? Quite a few people. Maybe you're one of them. And so, do we normalize every last name? Whew, that's a lot, right? We're talking about every last name in the world, because at Cincinnati State, I can tell you this: we're a melting pot of a lot of international students and U.S. students, which is a wonderful thing. I love it. However, maintaining a table with every possible name in it seems impossible. And when we search on every possible, when we search on these students' names like this, or when we search on something else like student ID or so on, with that said, we may not break that out into second normal form. Does that make sense? So if we can't maintain it, or we can't control it, we probably don't want to break it out, even though it meets the rule, even though there's redundant data in that last name. Hope that makes sense. We'll practice this more and more. You'll kind of get the hang of it. There really is no right answer or wrong answer. Some people might say, yes, it needs to be broken out based upon what my database is all about. So every database might be unique. Hope that makes sense. We're going to practice this a little bit more, but anyway, that's the second normal form.